we continue with our sessions, but we also want to say that this conference is fully live. So if you have any questions, drop in the chat. Let us know where you're watching us from, so we'll have more interaction. Our next session, next speaker is up next. We will talk about a new experimental language feature, Interceptors. Let me introduce you, Stefan. Hi, Stefan, welcome.
Hello, Aisha. Thank you very much for having me.
Of course, so excited to hear more about Interceptors. So take it over, please.
Hello, world. Welcome to Experimental C# Interceptors, AOT and performance for free. My name is Stefan Pölz. My alias is the Flashover, in short, F0x_F0. I'm a Microsoft MVP, JetBrains community contributor, co-host of the To Code or Not to Code livestream, and co-organizer of the .NET Devs.at meetup in Vienna. You see, I really love .NET, and I have dwelled a little bit into the previews of .NET 8 and C# 12, and found the experimental interceptors feature for me very interesting, because it's also related to source generators and to Roslyn in general, which is a topic that I am quite enthusiastic about. Well, I guess it's more of an obsession, but we will now find out what this is all about. First, a word of warning. So this is an experimental feature. It is available as a preview in the .NET 8 SDK, and it is subject to change. So this feature could stay the same for upcoming releases. It could change significantly, or it could be removed altogether. However, it got released so that we do get our hands on it and start experimenting with that experiment and can give feedback to the team and get an understanding what interceptors can do for us. And let me jump into the first demo right away and fulfill the first promise of this talk: performance for free. So I'm having here a benchmark.NET test class. We have two benchmarks where we use enum.getName from the BCL, from the system namespace, to get the name, in this case, from the myloglevel.critical enum constant, which will then literally return the string critical. And I'm having the same version again, but with a generated version. Well, it's not really a generated version. If we take a look at it, it is handwritten code. This is not by a generator, but I made it look like if it was generated, since this is code how it could look like by a generator. And when we compare now the general enum.getName that works with every enum on this world, compared to a very special case, getName enum, that only works for this very particular enum, but has special case code that is optimized for this enum, we see that the general purpose system enum.getName is slower than the generated special case version. Well, slower and faster is relative here. The difference is 1 nanosecond, but well, it's still half or double the difference depending on how you see it. And it suffices to make a point. Since .NET 6 and .NET 7 and .NET 8, there is more and more source generators coming out. For example, there's a source generator. We saw that in the system.json talk about how to deal with JSON. There's also one for Logger, one for regex, where a source generator creates a special case implementation, which then is bound to be faster and also more trimmable and AOT-friendly. And the thing is, now we basically have to trigger this source generator, and we have to also now use this new generated type in this case in order to get the special case, the very performance special case behavior. So it's more of an opt-in. So wouldn't it be cool if we wouldn't have to change any code and still get the performance boost? This is what source generators, interceptors, could do for us. So all I do, not changing any code, just adding this freshly pushed NuGet package to the project. Let's make sure everything is saved. And run the benchmarks again. What I'm now hoping is that a source generator is kicking in, which creates an interceptor. And the interceptor now should, as the name suggests, intercept this call, enum.getName, this invocation of this method, and reroute it to a different special case method. If we take a look in Visual Studio, in the Dependencies tab, Analyzers, we see through this new NuGet package that we added, now analyzers are there. Source generators are technically analyzers. There is now a new analyzer namespace, and here is a new document created. And if we take a look at this, this now actually is a source-generated document. We can see this by the warning up here. It says this file is auto-generated. Adding it cannot even be edited. And this also creates this very special case, enum.getName, which only works for this my log level and is not general purpose, but there is also the intercepts location attribute on there. And this now should basically, without changing that call, reroute to this new method. And the benchmarks have completed, and we now see that the call from system enum getName also now has the same speed as the generated one, because they now both call into special case methods. However, from the source level, we don't really see that this call is intercepted. Hovering it, I still believe it's system.enum.getName call, but during the compilation, this method invocation is actually swapped out. And this is what interceptors can do for us. So I mentioned this attribute. The anatomy of an interceptor is it is basically a method that is attributed with this attribute, the intercepts location attribute. Since interceptors are an experimental feature, this attribute does not exist in the BCL yet, because once it is in the BCL, it basically needs to be there forever. It's really hard to deprecate or even remove types from the BCL. So the team now decided, okay, the feature still works, but we don't provide this attribute, we don't emit this attribute, but I can provide this attribute myself. The compiler, Roslyn, still respects this attribute, basically trying to find it. If it finds it, then calls may be intercepted. And this is the anatomy of a This is the anatomy of this attribute. So it's just a regular attribute that has 3 parameters: the file path as a string, a line, and a character. And this is really the location of the source code that we want to intercept, that we want to reroute this method invocation from. We also see that I did this here as a file because if we have, since source generators now have to emit this type in order to produce interceptors, but if we have multiple interceptors creating the same type in the same namespace, it has to be in system.runtime.compiler-service, this could cause type ambiguities. So it's best to do a file, a C#11 file local type, and emit the attribute alongside your source code that you generate. And now the method that gets attributed with this attribute now fulfills the promise. It provides a file path where we want to intercept from, a line, and a character. And then it has to have a matching signature. For example, I'm having here a void method that takes a string. This would be compatible with console.writeLine. And if this console.writeLine was on line 2, we have here the line 2. And if this invocation was in my drive C code program.cs, then all I need is that the invocation is on character number 9, which in this case is 1, 2, 3, 4, 5, 6, 7, 8, 9. So we see after the dot, so between the dot and the beginning of the method name that is invoked is the location of the interceptor. So the rules of interception are this only works for C#. It's not strictly speaking a C# feature, but it's a feature for the C# compiler. It technically could work with Visual Basic, but it doesn't. It only supported currently for C#. It only allows intercepting ordinary methods. So we can't intercept constructors, or we cannot intercept local functions. As a matter of fact, there is a backing type in Roslyn. Roslyn is the .NET compiler platform, so the compiler for both C# and Visual Basic languages. And if we take a look at my second favorite site, which is sourceroslyn.io, my favorite site is source.net, which is a source browser for the BCL and .NET runtime. And sourceroslyn.io is a source browser for the Roslyn codebase. And there is a type method kind, and only ordinary methods can be intercepted. So currently we cannot intercept properties, although under the hood, the getter and the setter actually get turned into methods, but still currently it only works for ordinary methods. The interceptor, which is a method that has this attribute, cannot be in a generic type. But if the call that we want to intercept is in a generic type, then we basically use the sum of all of these generic types. So let's assume we have a generic type and one generic method. Then the interceptor is a non-generic type, but has 2 generic type parameters, so the sum of all generics. One interceptor method can have one or multiple intercepts location attribute, as long as the signature matches. But we can't have multiple intercepts location referring to the same location, because this would be an ambiguity which one to take. It must be unambiguous. Also already mentioned, we require a matching signature that includes the return type. It includes the parameters, including their refness. So if it's an out, a ref, or an in parameter. But the name doesn't matter. The name could be anything. But it must be accessible from the call that we want to reroute from. Since we are in the same compilation, we can only intercept code that basically we own in the same compilation. In our C# code, internal would do just fine. And we can intercept both static and instance methods, and instance methods are intercepted as extension methods. Now, let's jump in a demo and let's produce our own handwritten interceptor. So I'm having here a small little application, have a my class reference. I invoke a bunch of static methods with some strings, and I also invoke here an instance method. If you take a look at our class declaration, we have here the instance methods, takes an integer, returns an integer, adds 4 to it in the middle, and a static method that just console.writelines the string. And now we want to manually intercept some of these invocations. So let's simulate that this now would be a source-generated document. Let's put this side by side. And we see here we are in a non-generic type. So interceptors must be in a non-generic type. Here is our first interceptor. Let's include this attribute. Let's say I want to intercept this method here. So we need to find this character in line 6 in this file. And this character is, if we click here in Visual Studio at the bottom right, if we zoom in, we see the line and the character. So it's line 6, character 29. If we enter that, currently it says this is invalid because it also checks it must match. There must be something interceptable. Otherwise, it doesn't compile. 6 and, did you say 29? 29, yes. And it must be this file location. And it is the full path of the location. So this is already a clear signal that this is not meant to actually be written manually, but produced by a source generator. Because now what would I do if I have cross-platform code that I want to compile on Windows and also on non-Windows systems? Then those files paths wouldn't work anymore. Since this is an instance method, I need to pass the containing type as a this parameter, similar to an extension method. Well, actually, it is an extension method. So we pass this. Now, instance method takes one integer. So we have one integer here. The names don't matter. Names don't matter. But the types really do. We return an integer and we return an integer here. So if we regularly run this application, we get, oops, I ran this before already. Let's comment it out again. Run the application. So we pass in 4, we add 4, so this should print 8. And there it is, we have an 8. Now I don't change the original source code, I just change the interceptor. Now intercepts this very call, reroutes it to go here and returns a 12 instead. And running this code now, instead of the 8, we should have a 2. Oh yeah, I should save the file. Saving the file, now we have a 12 instead. So this call was intercepted. This method is no longer called. What if I throw new not supported exception? I did save this time. Running the code, it doesn't crash because this method really is not invoked. This invocation here is intercepted. You can think of the intercepts location attribute as a come from. So like the opposite of a go to. I see here, I want to go into this method. I want to come from this location here. And now let's also intercept some of these static methods. Since they are static, we don't pass a this parameter into this method. Signature still has to match, so we have a void method that takes a string, void method that takes a string. It's also internal, it's accessible. If it was private, it wouldn't be accessible, and we should get an error shortly. If I try to build it, then yeah. Oh, it's actually a different error, so let's fix that before. Let's intercept this SDK string here. So this is line number 8, character number 9, which is exactly here. 8 and 9. Running this. Now it says it doesn't work because it's not accessible. So it needs to be at least internal. And now, instead of printing SDK 8.0.100, it prints intercepted SDK, because this is what the interceptor does. It prints intercepted and the original string. Now from one interceptor, we can have multiple come froms. So let's also intercept the next line, the Roslyn line. So we can have, as long as the signature matches, multiple interceptors going to, or going to the same location, coming from different locations. And now both are intercepted. If I have another interceptor that tries to intercept the same location, I'm also doing 8, 9. This location is already intercepted. We get an error which says we try to intercept multiple times the same location. Now that's ambiguous. And what we see is, yeah, this is really meant to be source generated, because what if I happen to, let's remove that again. What if I happen to add a return here? Now, the file lines have changed, or I do a tab here, or not the characters have changed. So this is really meant to be done from a source generator. But with this, we have a source generator that can now do a lot of powerful things with interceptors. Now, I forgot one thing to mention. I also added this Interceptors preview namespace MS-build property. If I were to remove that and try to build, we get a compiler error telling us, okay, interceptors are an experimental feature. You need to explicitly opt in and need to state the namespace of the interceptor. So we basically need to explicitly say, hey, I know this namespace has interceptors. In our case, it's .NET Conf 2023.generated. And we are explicitly opting in and allowing .NET Conf 2023.generated that this namespace contains interceptors and may reroute method invocations. It's always good practice to also use the placeholder here, use the not overwrite all interceptor preview namespaces, but append to the existing interceptor preview namespaces, because maybe in the project build, MS build hierarchy, previously earlier in the hierarchy, we already had some other components asking for this preview namespace to be enabled. Which brings me now to some details about when was this feature really introduced. So we also have this in .NET 7. So this is not really a C# 12 feature, but it's a compiler feature, and it's also available as a preview, of course, same experiment, 7.0.4. The 4 is the feature band release, but it was a little bit different there. Maybe you have seen this from some discussions or some demos, that in the first version of this experiment, you just opted in by saying features interceptors preview, and then you opted into the interceptors feature in general, not only for this particular namespace. In .NET 8, it was added in preview 6. And since the release candidate 2, and also now in the full stable 8 release, we now have this interceptors preview namespace where we need to explicitly declare which namespaces we want to allow to contain interceptors. The second promise of this talk is native AOT. There have been already some talks about native AOT. I will reference to them at the end, but just to make this also a standalone experience, our current or our common compiler behavior so far is we have our C# code, Roslyn turns this into IL code. Now the IL package is a very portable package that we can deploy to a user machine or to our servers and then run them there. And when we execute these, then the just-in-time compiler will kick in and create architecture and OS machine code. So the flexibility is that we have one binary that we can basically run everywhere where .NET runs, unless we use any OS-specific features. The drawback is that we do have this just-in-time compilation here. And we still, although the just-in-time compiler is very, very powerful, but maybe for very short-lived apps, this is a bit of overhead, and the startup time takes longer, a little bit. And maybe we are in an environment where the JIT, just-in-time compilation, is not allowed. For that, .NET 7 started it, .NET 8 now pushing it massively, AOT, ahead of time compilation, where we still to IL, but then in the same process, now put this IL code and put it directly into machine code. And it's no longer this flexible IL code that we deploy that needs to be just-in-time compiled, but actual machine code that is my OS architecture and machine architecture specific. Now, the advantage is there is no just-in-time compilation, so the startup time is pretty much instant. The drawback is we cannot use any JIT compilation features. For example, system.regex is the compiled version of it with the flag compile, is using IL emit under the hood. So as an optimization, at runtime, it emits new IL code that is then at runtime just-in-time compiled. Now, without this feature, we can't use this anymore. And usually more and more source generators, like at regex source generator, are now trying to shift this just-in-time complexity to the Roslyn compile complexity already on the source code level, so that this doesn't need to be just-in-time compiled. And one other use case is that is also available in .NET 8, ASP.NET Core. There is a native AOT template for ASP.NET Core Web API, and with that we also get the publish AOT to true. And if I were to publish this, there's a different demo already from the conference. It's very fast in startup time. But what if we are in a scenario we don't have? What if we? So how is this enabled? Because the map.get methods under the hood actually do emit IL code at runtime. So they do both reference dynamic code, which requires the JIT, and they also have unreferenced code, so that use reflection, which means they're hard to trim as well. So how does this still work? If I were to disable publish AOT, but still enable trimming for this app, we will soon get warnings for those two map.gets saying that those are attributed with requires unreferenced code. So those are really hard to trim, those methods. But if we do publish AOT, why do these warnings disappear? Because of an interceptor that comes with the ASP.NET Core runtime. And if we take a look at the analyzers, there is the request delegate generator. And this request delegate generator, again, it's a generated document. It does emit intercept's location because it needs it, and now has special case map get implementations. And we see this comes from program CS line 21, character 10, which is exactly here, and the second method down there is there. So those actual map.gets, which are hard to trim and require the JIT, are no longer invoked because their calls are rerouted to something source generated. So the just-in-time complexity at runtime is moved to compile time, which makes this app both trim friendly and AOT friendly. And this is the promise of Interceptors, to give performance and AOT for free, because we didn't have to change any code. The source generator is taking care of that with Interceptors. Now, a small word of warning: with great power comes great responsibility. We could intercept all of our source code. I could make console.writeline do something totally different. Now, it's an experiment. We need to find out where we go with these features, what patterns will emerge. But currently, I would assume that the principle of least surprise, so an interceptor shouldn't really change the observable behavior. It should use a more efficient implementation that saves performance, makes it more trimmable, more AOT friendly, and most likely a combination of all three. Now, if you want to try Interceptors, download the .NET 8 SSK. Everything you need is in there. If you want to give the generator that I tried in the beginning, the enum generator, a try, that's flashover.generator. I linked the proposal and feature specification with more details about Interceptors, and also a video from the language and runtime standard community where this feature was publicly discussed, but there was a community stand-up with a Q&A session there. Now, perhaps there is maybe time for one question. I'm afraid I won't be able to answer all of them. If you have any questions, then please reach out to me afterwards.
Thanks, Stefan. We actually have one question. I think you can explain this really quickly. How source generators are faster than ordinary code in your first example?
So the source generator is not faster. Everything that a source generator just creates C# code. So everything that a source generator generates, I could also write manually, but it's most likely very tedious. For example, the enum example, if I were to add or remove constants from this enum, I would also need to adapt this very special case code. So everything a generator can do, you can do too, but the generator does it automatically for us. So it's very convenient.
I think we can go for one more question. So one question is about, is it possible to add analyzer that checks for interceptors?
Yes. I think, I'm not entirely sure if the analyzer, I'm not 100% certain if the analyzer sees source-generated code. Well, if it was a handwritten interceptor, then definitely yes. If it's a generator, I'm not 100% certain. I need to check up on that. Actually, on my stream in 2 weeks, we have the next session. We're actually trying to build a .NET tool that goes into your project, searches all the interceptors, and trying to list them. But since it's a .NET tool that's basically a little bit later in the pipeline, I'm not certain if an analyzer could do that too. But technically, it could. There may be a problem, chicken and egg problem, which comes first.
Okay, so one last question. Do you have any more videos about interceptors and source generators?
So about interceptors per se, there is not too much materials yet because that's a brand new experiment feature, but I can imagine a lot of content will emerge. There is some shorter videos on YouTube and the GitHub discussion that are linked. About source generators, there is a ton of content out there. Since source generators are available since .NET 5, is this now 3 years? And in the BCL, we got source generators since .NET 6 and 7 and now in 8. So there is a lot of knowledge about source generators already. I have a couple of talks on my YouTube channel, but there is also great other content on YouTube.
Awesome. And I will close out with the most asked question. What tool do you use for drawing the arrows on your screen?
So that's a cool tool, Zoom It, which
Zoom
is
It,
part of the
yes.
sysinternal suite, but it's Windows only. I'm not sure if there is a non-Windows similar alternative to that.
Awesome. Thank you so much. It was an awesome session. I learned a lot too. I didn't actually even know about interceptors before. And thank you so much for joining, Stefan. I guess we'll see you next year.
Oh, that would be amazing. Thank you very much for having me. It was fun. Goodbye.
Goodbye.